In a territory where most land loses its vitality within 3 years, regions of deeply black earth within the Amazon have sustained human populations for more than 2 millennia, requiring no modern plant food. Archaeologists have uncovered millions of acres of this engineered landscape, challenging previous understandings of ancient agricultural capabilities. Yet, if this soil technology promised perpetual fertility, why was it abandoned globally? The answer contradicts prevailing beliefs perpetuated by large-scale agriculture and reveals a method for creating a self-sustaining soil system that remains largely unknown. A spade penetrates the forest floor, displacing a thin layer of foliage to expose a secret concealed for centuries. Instead of the pale, lifeless yellow soil typical of most Amazonian regions, a profound black stratum extends like a shadow beneath the surface. This is not an optical illusion. The very earth here is transformed. Archaeologists routinely measure the depth of this layer, which can be as much as half a meter thick, densely packed with dark, friable material, interspersed with ancient pottery fragments and charcoal bits. In all directions, the surrounding soil remains acidic, depleted, and distinctly reddish. However, within these dark patches, crops flourish against all odds. Laboratory analyses quantify this phenomenon. Carbon dating places the age of this soil over 2,000 years ago, confirming its creation long before European navigators reached the Amazon. The chemical signature is unmistakable, with concentrations of phosphorus, calcium, and stable carbon significantly surpassing those found in the native earth. Even after centuries of rainfall and tropical warmth, its fertility endures undiminished. Satellite imagery and land surveys have begun to unveil the true extent of this phenomenon. These black earth enclaves are distributed across millions of acres, occasionally extending for kilometers, invariably bordered by the thin, exhausted soils characteristic of the basin. Where the dark soil ceases, the potential for abundance vanishes. Farmers cultivating the yellow soil witness their fields degrade after a few seasons. Conversely, within the black earth, the same land has supported generations of harvests without reliance on commercial fertilizers. No living person today can recall the creation of this soil. Its origins are lost to antiquity, yet its potency is indisputable. In a landscape where fertility is ephemeral and the jungle relentlessly reclaims all, these sections stand as irrefutable evidence that someone once mastered the art of enduring abundance. Who fashioned this improbable ground, and how did they achieve it? In 1541, as the Spanish explorer Francisco de Orellana navigated the Amazon, his chronicler Gaspar de Carvajal documented vast settlements, cultivated fields, and a population so dense it seemed impossible for the heart of a rainforest. For centuries, these accounts were dismissed as fanciful. Later explorers found only dense jungle and silence, not the thriving cities Orellana described. However, the truth lay hidden beneath the canopy, etched not in stone, but in the very soil. Modern archaeologists, equipped with satellite technology and ground-penetrating radar, began to map the Amazon in a new manner. Instead of seeking ruins, they traced the contours of ancient habitations through the distribution patterns of this black earth. These were not isolated gardens. Millions of acres of engineered soil spread in clusters along waterways, forming a concealed map of ancient human presence. In some areas, the dark earth blankets entire landscapes, occasionally spanning kilometers, consistently marked by layers of pottery shards, animal bones, and the distinct signature of human activity. Michael Heckenberger and his team, collaborating with the Kwikoro people in the Upper Xingu region, unearthed networks of villages interconnected by straight thoroughfares and surrounded by dark, fertile earth. Their research revealed a unique form of urbanism in the Amazon, characterized not by stone monuments, but by a complex arrangement of plazas, causeways, and engineered soils supporting thousands. The earth itself served as a living monument, preserving evidence of sustained agriculture and sophisticated societies where outsiders once perceived only wilderness. Every handful of black earth narrates a tale of meticulous stewardship. Layers of pottery fragments and domestic waste chronicle centuries of habitation. Settlement analyses reveal that these patches are not randomly distributed. They congregate where people resided, farmed, and shaped their lives. The scale is astonishing. Estimates suggest that up to 10% of arable Amazonian land bears the imprint of this ancient engineering, substantiating Oriana's reports of populous cities concealed in plain sight. What was once considered mythical is now mapped in the very soil, demanding a reconsideration of these people's achievements. The subsequent inquiry is not whether they created this abundance, but how they sustained it for millennia. A soil scientist gently crushes a fragment of the black earth between their fingers. Under microscopic examination, the secret becomes discernible. A honeycomb of vacant tunnels and chambers winding in every direction. Each gram of this carbonaceous matrix possesses more internal surface area than a small dwelling, equating to approximately 2,000 to 5,000 square feet. These are not merely cracks or random apertures. They are the petrified impressions of ancient plant cells, transformed by heat and time into a permanent scaffolding. This material is not ash, nor is it the light, fluffy charcoal remnants of a campfire. It is biochar, generated through a method known as pyrolysis, the combustion of organic matter in extremely low oxygen levels, thereby preserving its structure while volatile components are expelled. The outcome is a material unlike any found naturally. The pores within biochar are measured in microns and nanometers, forming an intricate maze capable of retaining water, nutrients, and, critically, life. Soil bacteria and fungi colonize these protected spaces, sheltered from desiccation, predators, and the constant leaching effect of rain. The scientist clarifies that this porous network functions as a microbial apartment complex, transforming the soil into a living metropolis. Each chamber hosts a distinct occupant: nitrogen-fixing bacteria, phosphate-solubilizing fungi, and a multitude of invisible laborers that recycle nutrients and build fertility from within. The structural integrity of biochar distinguishes it from all other soil amendments. Chemical fertilizers dissolve and are washed away. Compost decomposes and disappears. However, the carbon skeleton of biochar endures. Its aromatic rings and condensed carbon bonds resist decomposition for centuries, occasionally millennia. This stability underpins Terra Preta's reputation for inexhaustible fertility. The scientist emphasizes that, unlike the temporary boost provided by synthetic fertilizers, biochar establishes a framework that can be rejuvenated repeatedly. Nutrients adhere to the surfaces within the pores, held in place by cation exchange sites that function like magnets. Water clings to the pore walls, remaining accessible to roots long after the surface soil has dried. The true marvel, the scientist explains, lies not solely in the chemistry, but in the architecture itself. A single handful of this substance harbors more habitat for microorganisms than an entire meadow of living grass. The scale is almost unfathomable. 1 gram, less than a sugar cube, offers thousands of square feet of terrain for the soil's hidden ecosystem. Over extended periods, as organic matter cycles through, the biochar matrix evolves into a living repository, storing nutrients and supporting the intricate web of life that maintains soil productivity. This invisible, sponge-like structure is why Terra Preta has defied the Amazon's harsh climate for thousands of years. The ancient engineers who created it did not merely add nutrients. They constructed a permanent infrastructure, a subterranean coral reef. This physical foundation, more than any specific recipe or ingredient, elucidates why their soil continues to nourish crops long after their cities have vanished. The subsequent step is to observe how this structure translates into tangible abundance, how field data corroborates microscopic revelations. A series of garden beds extends across a small homestead. Each bed contains the same crop, receives water from the same source, and is exposed to identical sunlight. Yet the similarities end there. In the first bed, the plants appear sparse and pale, their leaves curling at the edges. This is the control. Plain local soil without any additions. In the second, the soil has been augmented with commercial fertilizer. The plants look healthier, more vibrant and taller, but exhibit certain issues. Following a heavy rain, puddles form and the lower leaves yellow. In the third bed, the soil is dark and friable, speckled with charcoal fragments that were charged weeks prior with compost tea. Here, the plants significantly overshadow their counterparts, boasting thick stems, lustrous leaves, and roots penetrating deeply into the ground. The gardener, holding a notebook, measures the rows. By the end of the season, the data tells a clear story. In the control bed, each tomato plant yields only a small quantity of fruit before the stems begin to wilt. The fertilized bed produces more, almost double. But by late summer, the lower leaves are spotted, and the underlying soil feels firm and dry. In the biochar amended bed, the plants are 3 to 8 times larger than those in the control, heavy with fruit, and continuously producing new growth. As the season concludes, the soil remains loose and moist, even after weeks without rain. A simple soil probe reveals the underlying reason. In the control and fertilizer plots, water drains rapidly, leaving the soil parched within days. Nutrient tests indicate that after a rainstorm, most of the added fertilizer has leached beyond the root zone, making it inaccessible to the plants. Only about 30 to 50% of the nitrogen from the fertilizer is effectively absorbed by the crop. The remainder is lost, either washing into the subsoil or running off into nearby drainage ditches. In the biochar bed, the probe retrieves a cohesive clump of soil that retains its shape, consistently damp and cool to the touch. Laboratory analysis confirms that most of the nutrients incorporated before planting are still present, sequestered within the microscopic pores of the biochar. These botanical elements draw upon this reserve as needed, maintaining a consistent water content in the soil even during arid periods. In certain years, the horticulturist hydrates the biochar beds with half the frequency compared to others. The figures exhibit uniformity. The biochar plot yields 3 to 8 times more overall biomass than its control counterpart, and retains significantly more nutrients. Instead of being washed away with every rain, nitrogen and potassium persist in the root zone, nourishing the vegetation for months. The distinction is apparent above ground, yet the true activity unfolds beneath the surface. The biochar matrix functions as a perpetual sponge, absorbing moisture and nutrients and gradually releasing them. Chemical fertilizers provide an immediate boost, but their efficacy quickly diminishes, necessitating repeated applications by the gardener. Biochar transforms the soil into a dynamic system, amplifying the impact of every measure of compost or manure. By season's end, the biochar bed is not merely more productive, it is more resilient. The plants endure drought and heavy rainfall, and the soil's richness increases annually. The gardener closes their journal, already formulating plans for the subsequent year's experiment. Nevertheless, the outcomes are unmistakable. Once such soil infrastructure is established, one ceases to source their yield from a package and begins to cultivate it sustainably, year after year. When the initial European maladies swept through the Amazon, the civilization that created the Black Earth vanished almost instantaneously. Smallpox, measles, and influenza preceded settlers, traveling along established trade routes and riverbanks. Within a century, up to 90% of the indigenous population had perished. Entire settlements were deserted, their cultivated lands reclaimed by the forest. The sophisticated knowledge of soil cultivation, transmitted through generations, was fragmented and silenced, with no written records remaining. What persisted was the soil itself, a silent testament to extinguished lives. As centuries passed, the dark earth remained, but the methodology receded from living memory. Colonial authorities and subsequent agricultural specialists perceived only untouched wilderness and decay. When industrial agriculture became prevalent, the focus shifted to immediate solutions: bags of chemical fertilizer, yearly applications, and an unceasing cycle of procurement and distribution. The nascent system relied on recurring transactions. Fertility became a subscription. Each year, farmers were instructed to purchase increased quantities of nitrogen, phosphorus, and potassium, as these nutrients would be leached away by the first substantial rainfall. The implication was clear: your soil is not your own. Your harvest is leased from a bag. Meanwhile, a profound misapprehension became entrenched. Agricultural advisories cautioned against incinerating crop residues, contending that fire eradicated nitrogen and rendered the soil infertile. They failed to differentiate between ash, the residue of intense combustion, and char, the stable carbon framework essential for black earth. The ancient practice of controlled charring was encompassed within a sweeping prohibition. Extension agents and textbooks indiscriminately grouped all forms of burning, obliterating the nuance that once transformed waste into prosperity. The outcome is a system that thrives on depletion. Every storm that leaches fertilizer from a field presents another opportunity to market additional products. The singular method capable of disrupting this cycle of self-renewing soil infrastructure was overlooked, not due to its failure, but because of its extraordinary success. The Black Earth stands as a quiet defiance against a paradigm reliant on scarcity. The pertinent question now is whether anyone will opt to reclaim that forfeited abundance. A gardener stands beside a weathered metallic pail, their hands smudged with charcoal dust. The procedure commences with arid, unprocessed branches and twigs, explicitly avoiding painted wood or pressure-treated lumber. Each segment is reduced and introduced into a modest fire pit, designed for high-heat combustion but shielded from the wind. Oxygen regulation is paramount. Excessive air transforms the wood into ash, while insufficient air causes it to smolder without thorough charring. The objective is to achieve a deep black carbon that fragments easily, rather than a pile of gray powder. Once the flames subside and the last wisps of smoke dissipate, the char is doused with water, halting the reaction and preserving its porous structure. The subsequent stage distinguishes between prosperity and disappointment. Raw biochar, fresh from the flames, acts as an inert sponge, yearning for nutrients but empty. If directly incorporated into the soil, it can deprive plants of nitrogen in the initial growing season. The solution is charging. The gardener pours the cooled char into the bucket, then introduces a nutrient-rich liquid, compost tea, a diluted manure slurry, or even a blend of water and fresh urine, consistently maintaining a safe ratio and never undiluted. A 10-to-1 dilution is standard for urine. The mixture in the bucket is stirred, then left to sit for 2 weeks. Every few days the mixture is aerated, enabling microbes to establish themselves within the char's intricate channels. After 14 days, the biochar has absorbed a vibrant concoction of nutrients and beneficial bacteria. The gardener drains the liquid, allowing the char to dry until it is damp but not dripping. It is now prepared for the garden. A singular application, blended into the top 6 inches of soil, establishes a permanent framework. There is no requirement to repeat this process annually. The charged biochar integrates into the soil itself, retaining water during dry spells, nourishing roots during lean periods, and providing a sanctuary for microbes. With a few hours of labor and a simple bucket, the gardener has created a soil system that will operate continuously, season after season, without recurring costs. Safety is paramount. Gloves should be worn to prevent skin contact with dust. A mask is advisable if the char is exceptionally fine, and under no circumstances should toxic materials be burned. The method is straightforward, reproducible, and proven. The most challenging aspect is accepting that such a simple approach can yield such enduring results. Chemical fertilizers currently dominate over 90% of global agricultural land. Nevertheless, our soil is deteriorating at a faster rate than at any period in recorded history. The Amazon's black earth demonstrates that sustained fertility is achievable if we choose it. Will we continue to obtain our harvest from synthetic cycles, or will we reconstruct what endures for millennia? The earth remembers. The question is, do we? Share your thoughts in the comments below.